Many schools and publishers have come to rely on automated AI text detectors as their primary line of defense, hoping these tools reliably separate human thought from machine generation. But the logic behind these detectors is fragile. A writer recently took a paragraph graded as 100% AI generated and made a single edit, swapping one em dash for a colon. That character change alone flipped the detector's verdict, causing it to grade the exact same text as 100% human. This lack of reliability led OpenAI to quietly disband its own text detection team. They found it impossible to build a system that could consistently distinguish between a machine's output and a person's writing. These specific failures in detection suggest that our current digital methods for verifying authenticity are unable to keep pace with the technology they are meant to track. Standardized tests are the primary way we measure how smart an AI model is becoming. One common, informal test involves asking a model to draw something absurd, like a pelican riding a bicycle. To see if labs were cheating on these tests, researchers ran an experiment called pelican maxing. They generated 1,008 images across 7 different models to see if labs were hard-coding their AI to specifically ace this one prompt. Standardized tests lose their value as a benchmark the moment they become famous. Once an engineering team knows exactly what the test covers, they can optimize for the score rather than general capability. If these digital scores and benchmarks are easily gamed, we have to look for the true measure of a model's power in a different environment. OpenAI is moving away from the unpredictable chatbot model with its new Presence platform. It is a system built for businesses that need AI to follow strict rules rather than explore creative possibilities. This platform enforces rigid enterprise guardrails. If an agent hits a problem it isn't clear to solve, it follows a set of standard operating procedures to automatically escalate the call to a human. Major banking and telecom customers are already using this system to handle phone support, with Presence resolving 75% of inbound calls without any human assistance. Corporate AI is becoming a form of infrastructure plumbing, where the priority is enforcing compliance rather than generating magic. Training a modern AI model requires an immense amount of physical memory. Just tracking the math behind the model can consume more hardware capacity than most servers can provide. Engineers are using new optimizers like Skew-Atom to fight this. By changing how the model is tracked during training, they've compressed the memory requirement from over 50 gigabytes down to barely 1 gigabyte. Meanwhile, tools like Gigatoken process data at a gigabyte per second, struggling to keep up with how fast these models consume information. These extreme software optimizations are driven by a necessity to lower costs. The math has to become more efficient to prevent the massive physical expenses of training from making the technology unsustainable. In rural Georgia, OpenAI is developing a 1,400-acre data center campus known as Project Camellia, an investment of over $20 billion in physical infrastructure. The facility is planned for a 3.2 gigawatt capacity, with OpenAI locking up energy contracts through the year 2032 to ensure it has the power it needs. A 3.2 gigawatt draw is difficult to visualize until you compare it to the energy needs of a standard city. When this single campus is at full scale, it will draw enough power for more than 2 million homes. The development of these models now relies on massive land acquisitions and municipal power contracts in rural America. The United States government is currently running the Genesis mission, a push to double the pace of American scientific discovery within a single decade. As part of this mission, Google and OpenAI are providing the Department of Energy with direct access to their frontier models and high-performance compute tokens. Integrating these models into federal laboratories transforms artificial intelligence into a sovereign tool for national infrastructure and scientific dominance. While the industry often focuses on massive, general-purpose models, a new class of small, hyper-specialized tools is beginning to outperform them. A financial model called FinRag-12b recently beat giants like GPT 4.1 on citation accuracy. It did so while operating at roughly 1/50th of the cost. Raw algorithmic size is becoming a liability. Narrow, resource-efficient specialization is the new standard of value. Cooling water, silicon chips, and electricity have become the primary bottlenecks for AI advancement. Some major open-source models have been forced to pause signups or limit access because there simply aren't enough physical GPUs in existence to serve the incoming demand. The cloud is a physical machine made of silicon and steel. Whoever commands the Earth's raw materials and power grid will win the AI war.